So let's step out and just first understand this whole semiconductor value chain, right? I'm assuming a chip starts out as a design, right? So can you help us walk through the whole process by which possibly I see it in a mobile phone, some years after a design?
Yeah. So yes, you have the chip design process, which by itself is a fairly complex process. You go through an abstractization of what you want the chip architecture to be, and then it manifests itself in a physical layout of the chip itself. But there's a lot of intermediate steps related to design, analysis, validation of what you're trying to make. And that works very closely, the design process, with where the chip gets manufactured, what we call a wafer fab. And the wafer fab has associated design rules related to manufacturing. So then you have to integrate these design rules, which are for manufacturing, along with your design tools. And there's an entire industry called the EDA industry, the electronic design automation industry, which then creates these tools for making sure that you can do the design and the design is relevant to how the manufacturing process works. So that when you manufacture the chip, all the considerations for a high yielding process and the chip comes out functioning as best as you want it to function. Once that is done, then it goes through what we call an assembly and test process. And today, the complexities of, even if you take a cell phone chip, it's got multiple components to it. And you have now multiple components you need to optimize. And the back end of the whole process is what we call semiconductor packaging. And today, what happens is you have to make sure that you're partitioning the architecture of the overall system upfront during the chip design phase. So you have the chip design and package design. What you have to do now is there are companies called EDA companies, electronic design automation companies, that actually integrate design flows. And there's been a lot of, I would say, consolidation in some of these design tools where you can now get a full suite of tools which starts from all the way from a chip architecture to board design. And it's part of one big suite. And there is interoperability between these tools so they can talk to each other. And so what you do then is you optimize or you co-optimize your package layout, your package footprint, along with your chip footprint, so that now you're globally optimizing the entire, what we call the interconnect, all the way from the chip level to the motherboard level. Once that is done, then you go into what we call assembly and test process. So this is what we call the back end of manufacturing. The front end is the wafer fab, and the back end is assembly and test. So once the chip is made in the wafer fab, you get this big wafer from the silicon fab, and then it's individually cut into individual chips because you have multiple chips on the wafer. And then that goes into a separate factory called the assembly and test factory. And there you assemble these chips onto a package using different techniques, depending on the technology and the complexity of the chip you have. And then it goes through a test process. And once it passes all the tests, then you can send it to the customers who would buy these chips.